Hello and welcome to Tonight at 8 from the RSGB. In March 2021, most UK radio spectrum users, including radio amateurs, received a letter from Ofcom explaining that they'd soon be introducing new licence conditions aimed at protecting the general public from excessive radiation from wireless transmissions of over 10 watts EIRP. These new licence conditions were finalised and published by Ofcom in May, and the RSGB have been working on tools and guidance to help amateurs assess and report on their station's emissions. Well, joining us tonight is the chair of the RSGB EMC committee, John Rogers, M0JAV. Welcome to Tonight at 8, John.
Thank you very much, David, and it's good to have the opportunity to tell people a bit more about the work of the EMF committee, which is part of the EMC committee. And what I'm going to be doing tonight is, as well as doing a quick summary of the EMF limits, I'm going to be going through some real examples of using things like the calculator to do the assessments required by those new license regulations.
Yeah.
So back to you, David.
Thank you very much, John. And before your presentation, a reminder that if you're watching this on Monday, the 5th of July, then this is live. And you can add comments and ask questions on either BATC or YouTube at any time during the presentation or straight afterwards. Please include your first name and call sign if you have one within each message. And also please note that you can make this video stream fill your screen on most devices, usually by double clicking on the picture or pressing the full screen button. But now it's time to go back to John to find out how to assess your station against the ICNIRP EMF levels.
Okay, thank you, David. The work all started back in February and November of last year when Ofcom started to notify every spectrum user of their intention to introduce new regulations on EMF. And as David said in the introduction, that culminated in May of this year when those changes became effective. So what is the new license condition all about? Electromagnetic energy, such as that which comes out of our antennas, can be absorbed by a body and may cause a temperature rise, or it could cause electrostimulation, which is where the radio fields make the nerves tingle. Now, our bodies are fortunately very efficient at getting rid of this excess heat. We do things like vary the blood flow, we sweat, we breathe faster. But if the rate of heat generation exceeds the body's ability to remove it, prolonged overexposure can then lead to harmful effects. And it was this that was studied by ICNIRP, the International Commission on Non-Ionizing Radiation Protection, who derived basic restrictions based on a specific absorption rate measured in watts per kilogram of radio energy into the human body. However, it's difficult to measure or compute the actual SAR in living people. So what they've done is to say that compliance with basic restrictions can be demonstrated by ensuring that the level of emissions from any radio waves is below assessed reference levels. Now, this actually happens. The basic restrictions I've spoken about and the reference levels, but there are actually two sets of those. The first one is for people who are actually working on it, called the occupational levels, and the one which Ofcom have chosen to use for the limits in this new license condition, the general public limits. There are two types of exposure that you have to consider: local exposure and whole body exposure. And there are three types of measurements that have to be done. There's the peak measurement, which determines the electrostimulation below 10 megahertz. There's an average over 6 minutes for local and over 30 minutes for whole body. So if you look at a situation whereby you have an antenna transmitting, there will be an area around that which we call the exclusion zone, which is where the reference levels would be above the limit for that particular setup. Outside of that is a compliance zone, and that compliance zone is where members of the general public can be without exceeding the basic restrictions. This is perhaps the most important message of the whole presentation, and that is if there's nobody in an area, then the body can't absorb any energy. So the best way of making sure that you don't breach your license condition is to work out your exclusion zone and make sure there's nobody in it. Now, after a lot of work, including a lot of lobbying from people working with me on the EMF assessment of RSGB and ARRL, we've actually persuaded Ofcom and worked with them to help them produce a simpler guidance. If you saw the original version, it was much more complicated than the new one that came out on May the 18th. So we're now down to 4 steps. Step 1 is to determine if you need to comply. And this is the one that at the moment I would probably fill in because I don't have time to use my radios. So I'm spending all my time trying to help people with EMF. But seriously, when I am operating, then I need to go on to step 2, carry out a compliance check and define some exclusion zones. And that can be done in a number of ways. One clarification that came through at the very last moment in the guidance was that you can use either the ICNIRP 1998 reference levels or the ICNIRP 2020 reference levels, but you can't mix the two in the same calculation. You can use either the Ofcom calculator or the RSGB calculator or another approved calculator or detailed modelling, or you can look up one of our pre-assessed configurations. I'll be concentrating tonight mainly on using the RSGB EMF Calculator. Step 3 is having decided from your compliance check where your exclusion zones are, is to outline how you're going to make sure that nobody is in that exclusion zone when you transmit. And step 4 is to keep a record of what you've done. So I think that is very simple, and I think that Ofcom have done their best to make it as clear as possible as to what amateurs need to do. Now, I will just say at this point, if at the end of all this, you still are having difficulty in meeting the compliance levels, you can go into a more detailed guide and do a lot more work in detailed modelling and demonstrate compliance, because by nature of its simplicity, these calculators give what's called a conservative value, which is a bit bigger than a detailed specific model for your situation would need. So if we have a look at the calculator, I'm sure most of you have seen this. Basically what you need to do is to fill in the yellow boxes. As you fill in the yellow boxes, you will specify the band, the power, the amount of time you're transmitting is a fraction of 6 minutes. You can specify the type of cable you use for the feeder, the length of the feeder, any other losses in the system, the type of antenna you use, what its minimum height is, and the calculator will then come up with an answer, which in this case is that the average EIRP is below 10 watts and the peak EIRP is below 100 watts. So your system is compliant if this is how you're set up. And this green message pops up on the calculator to inform you of that. The calculator is conservative, but if you can achieve the compliance distance that it requires you to, or you pass the low-carb compliance, then you don't need to do any more for that particular setup configuration. If we put the power up a bit such that the average EIRP is more than 10 watts and the peak is more than 100 watts, then the boxes down here come into play, and you can see that it's done a calculation and worked out that the Ofcom compliance distance is 3.6 meters. Now bear in mind that this is SSB processed, 400 watts, talking half the time, with a 20-meter feeder, only a half-wave dipole, 5 meters up in the air, and your compliance at 3.6 meters is a little bit more than the vertical separation between the top of the person and the relevant part of the antenna. So you need to create a small exclusion zone on the ground of about 1.5 meters around the shadow of the antenna. Or you need to move your antenna height up a little bit. Now, either of those will make you compliant. As the compliance distance is 3.6 meters, the height is 3.2 meters, and you either need, as I said, to raise the antenna or keep people more than 1.5 meters away, and you'll be compliant. But a number of people will realize that we are using the gain on the bore site of the beam of the antenna and assuming that that applies everywhere. Now, obviously, for a rotatable antenna, or one that rotates, that could be the case. But generally, any sort of beam antenna will have an elevation low. So when a mast-mounted beam is used, the gain that's being assumed will be higher than what is there in reality. So to produce a less conservative compliance distance, there's a directivity factor built into the RSGB calculator. And this allows you to enter how many dB down the elevation lobe is at that particular time. So you can calculate the elevation angle, which you then look up the beam pattern, and you can do that from the height and the separation. And you can repeat this for different accessible positions around the antenna, and that will define some exclusion zones. And I'm sure you know by now that what you need to do is to keep people out of those exclusion zones. So let's have another quick look at the calculator. This time I put in a directivity factor, which is very, very low, of only minus 2.2 dBs. But now what you see is that with the separation distance coming down, we've reduced the horizontal separation to be just a meter, which makes sense. So either you would need to move the antenna up to 6 meters, or you would need to look up for your particular antenna and the reasonable directivity factor, enter it in there until you get the horizontal separation down to 0. Now, what's really happening here is that the Ofcom calculator is limiting the answer to be the near field. So although we add in the directivity factor, it doesn't take us to the sort of separation we would want, because the calculator will not allow an answer that is less than lambda on 2 pi. A lot of people ask us why, when they change the power, does the answer stay at 3.4 meters? It's because, and I'll explain this towards the end of the presentation, it's because the reactive near field is the minimum answer that the calculators can give at this version of the calculator. So we need to do more detailed modeling if we want to take advantage of what's really happening due to the directivity factor. So what does more detailed modeling involve? This is an inverted V dipole with a person, and this one is showing the E field. The electric field is, of course, stronger where the voltage is higher. That's at the end of the antenna elements. Whereas by comparison, the H field is stronger in the middle where the current is maximum. Now, what we can do is use detailed modelling to work out, including power reflected from the antenna off the ground back up into the space, an exclusion zone for different power levels. So the outer boundary here is 400 watts, then you've got 300, 200, 150 watts input into the antenna. And what you can see is that at ground level, even at 400 watts, a person is not going to be exposed to over the reference levels. Now, in doing the integration across the height, then we represent the person as a dot at ground level. So we produced this in one of our so-called pre-assessed configurations, the only one published so far. It's Pack 1, it's for dipoles below 10 megahertz. So let's have a look at the exclusion zones. This time, let's have a look straight down on the antenna, and what we see is this bow tie pattern. And what it says is that for a given antenna height, then these are the exclusion zones that you need to set up. Because this is for a resonant dipole, and as you use it at frequencies that aren't exactly on resonance, and so the peak fields will move up and down the antenna a bit, we simplify that to rectangular exclusion zones. So the blue boundary on here is the 400 watt, and that's 2 meters from the wire for an 80 meter dipole. The red boundary for 100 watts is 1.1 meters, and the brown inner boundary for 10 watts is only half a meter. So what this is saying is that for an 80 meter dipole, providing you can keep 2 meters away from the nearest part of the antenna wire, then you can prove that you are compliant for an antenna at this height. This was published, and this is an extract. And what it says is that for the different bands, 160, 80, 60, and 40, and the different power levels, these are the minimum heights above ground level that are needed in order to achieve compliance. We just put a rider on this. There is another condition of EM fields, which is if somebody happens to touch one of the conductors, they could end up with an RF burn. So we actually recommend, good practice would be to maintain a separation of 2.2 meters from an area where people could be. And you'll notice that in no cases is the antenna lower than 2.2 meters, so that is also achieved. Similar thing can be done for the 40 meter inverted V, but this time it's set up in a configuration closer to what you might see if you were operating in the field. I've only shown half of the pattern because it's symmetrical, and so there's a half a bow tie, and this time for 40 meter inverted V, the distance is still 2 meters. But because the antenna is now lower than the minimum height that would be recommended, there is actually an exclusion zone at ground level, the red level on red part of this picture, where you would exceed the field if you were there. So what we recommend is a simple exclusion zone, a rectangle, which is shaded beige in this case. So how do you work out and how do you manage your exclusion zones? The first step is to work out where people could actually be, because if there's nobody there, they can't be exposed. If you produce a sketch showing these areas and where your antennas are, and include the separation to the accessible areas, then you can determine the compliance distances using the calculator, or you can use lookup tables for pre-assessed configurations. Draw the exclusion zones on your sketch map and make sure that nobody is in them when you're transmitting. So what you're really doing is identifying where the areas where people can be and the areas where the field strength can be too strong, and make sure they don't overlap. Take a record of that and your job's done. Let me give you a practical example. So if you go onto Google Earth and you look up your own location, then you can get a picture of your system. This here is a leftover antenna. Down here is a pump-up mast for a beam, and there are various wire antennas in this area. Adjacent to this property is a public area. There's a public footpath, so that's all accessible, except where people can't approach because of brambles and bushes and hedgerows, etc. So let's have a look at the next step on Google Earth, which will also measure distances. So now we can measure the distance from the antenna to the public footpath. We can see it's 22 meters. So knowing that, and even realizing that perhaps if they're walking a dog, they might get halfway in there, 10 meters, that tells me where I've got to manage my exclusion zone. Of course, that is the horizontal separation, and a 12-meter mast is going to give you quite a lot of separation from people anyway. So if you make sure no one is present in the accessible areas when you're transmitting, then that's done. As I said, reminding you that a single compliance distance assumes a sphere. The calculator flags low compliance, and that detailed modelling can give you the exclusion zones, and if you use external modelling, then you can end up with 3D pictures. But what you end up with basically in the end is an area where you shouldn't go, an exclusion zone, and an area where the public can pass without problems. So let's have a look at a real example. This is a VHF field day, 4, 6, 4, 2, 70 and 23. The power being used for each of those bands, the antenna heights, the cable losses, these are all calculated by different by the RSGB calculator, and then the results just tabulated here. You've got the antenna gains for the particular antennas, and that gives you an average EIRP and a compliance distance. Now, the way this was set up, all the masts were more than 12 meters from the gazebo. It was in a private field, and there was a sort of event fencing put up around to exclude the general public. And there were always somebody keeping an eye on what was going on the antenna field. If you wanted to calculate the combined effect of the two of these transmitting at once, what you need to do is say the 6 and the 2 were transmitting at the same time. Then you have to add the two powers up, and you come out with about 1800 watts, and then put that 1800 watts into the worst one, which in this case is 6 meters, and that gives you a distance of about 14 meters. So that defined the exclusion zone for this. Now, the method that is used there is a bit crude, but it is acceptable to Ofcom for when you have more than one transmitter running at the same time. Another real example might be our own National Radio Centre. They've got multiple bands, multiple antennas. They've got the stepper up on the roof. They've got dual beam antennas, and they've got various wire antennas set up as well. So for 40, 10 and 6, they operate in different modes. They use a 1K linear amp. Similarly for 80 and 40 meters. And up in the VHF, they've got a whole series of antennas and modes of operation. Now, what the guys, Martin and his people at the NRC have done is to run the calculator on each of these configurations. And for example, for RF, they have determined that the stepper being driven by 500 watts from the amplifier and using SSB processed is the worst case. Now, I just want to point out that although the power into the feeder is greater than 400 watts, by the time the losses of the feeder have been taken into account, the power is back below the 400 watt level, so it is legal to transmit in that way. The compliance distance that comes out is 7.3 meters, but your vertical separation for a 15-meter mast down to ground level is 13.2 meters, and because the 13.2 is greater than the 7.3, you can say that this particular configuration is compliant everywhere at ground level. If somebody was working on the roof up here, then they might not be compliant. So the simple way of doing it is to say if there is anybody working on the roof, which is 6 meters below the antenna, less than the 7.3 compliance zone, then you shouldn't transmit, or you should reduce the power you're transmitting. If you go to below 200 watts, then things are compliant even at 6 meters. The good news is that the office space below, which is 10 meters below the antenna, is far enough away, even ignoring any absorption by the building roof or any directivity factor of the antenna, you are still far enough away to be compliant. And I think this is an important principle that people don't understand. As long as you can achieve the compliance distance, then you are okay. And you don't need to model perfectly what absorption there is by the building roof or any of the other effects that we know will reduce the power, because you are achieving that compliance without needing to do so. For the VHF, a 2 meter dual beam, for example, the worst case was 400 watts, processed single sideband, and the distance came out at 10.8 meters. Now that was hard to achieve when the antenna was only 7.5 meters above the ground. But of course, we haven't at this stage considered the directivity factor. Now, for a good beam, the amount of energy that comes out below the antenna is going to be much less than that going in the direction you want it to go in. So I put in here a directivity factor of 9 dB. And what we see now is that the Ofcom compliance distance reduces to 3.8 meters. The vertical separation is 5.7 meters. So having done some more detailed modeling, we've been able to demonstrate compliance. However, for the 2 meter, 100 watts at 5.4 meters, we would have been compliant anyway, so we wouldn't bother to go in and do the more detailed work. If the calculators don't give you compliance, then you do have the option of going to antenna modeling in order to prove it. But there is a very big difficulty with antenna modeling, and that is that how you set up the segmentation for your various versions of NEC drastically impacts on the results that they give. Another example here of a GP2RS newsreader who is going simultaneously, because it's the same feed, 20 watts on 6 meters, 500 milliwatts on 70 SEMS, and a watt on 10.3 with the antennas. And we come up with the fact that each of those is compliant because the distance is easy to achieve. Even run together, the compliant distance is only 6 meters. And that's assuming 106 watts into 10 gigahertz. So I've added all of the different EIRPs up and assume they're going out through the 10.3 gigahertz system. I know it's not correct, but it's the way of demonstrating how to handle multiple simultaneous transmissions at one station. There's a list of the types of records you can keep. They're basically either the calculations you've done, the models you're relying on, or the steps you're taking to make sure that people don't get into the zone. So what is the calculation actually doing? These are the reference levels for general public exposure in the 2020 version of the standard. What you basically need to do is to make sure that the field strength at a given point is below the limits. Now, there are 3 types of limits. There's the peak exposure, which is shown here for the electric field and there for the magnetic field. There's the local exposure, that's the one for the electric field. And the whole body exposure, that's the one for the magnetic field. Now you have to show, for example, below 10 megahertz, compliance with both the E field strength, which is 83 volts per meter, and the lower of the H field strengths, which is this line. To simplify that, we have taken a table of a single frequency per band below 10 megahertz and just put down all of the values and then highlighted in red what the limiting values are. So the limiting values is the magnetic field whole body average, the peak electric field, and then there's limb currents. Limb currents are a difficult thing at the moment because they are expressed in milliamps flowing in a person's ankle, and there is as yet no reference level which says that a field of this strength will induce a limb current of this value. So that's being worked on by RSGB and ARRL experts in conjunction with the FCC, HP, Health Protection England, and Ofcom. It's also worth noting that where a time average is specified, that's defined in the methods of actually doing the averaging, and similarly where a spatial average is specified, that has to be done. So when you do your antenna modeling, you're not just looking at point values, but you're looking at averages over the right parts of where the person would be. So having got your limits, the next thing you need to do is to convert the EIRP into an E and H field level so you compare it with the limits. Now, close to the antenna, that is difficult to do. Once you get more than lambda over 2 pi away from the antenna, then you know the impedance is constant. The wave impedance is 377 ohms once you get out of the near field. So that allows E and H to be calculated from the power very simply. Now, if you assume that in the transition zone here, the characteristic impedance is 377 ohms, and if we can prove that that is a conservative estimate, then we can then produce near fields that are more than lambda by 4 pi away from the antenna. And we need to do some once-off modeling in order to see what the lower limits are. Currently, the current version of the calculator is using lambda on 2 pi. But we're working on trying to prove that you can change that. So that's just trying to explain how the E and H fields are calculated from the power. This is a bit of a frightening diagram, but it is what actually comes out of modelling the absorption of a person, or the reference levels that a person would see over his body if he was at a certain X position and a certain Z position away from this antenna. So the aim is that by doing this modelling, and if we have a look at this a little bit more, this particular line I'm following here is the 400 watt compliance contour. So that is for this particular antenna, it's about 15 meters from the actual antenna itself. More importantly, though, if you ignore the grey zone, which is for high power, so we can do the work for the FCC at the same time, anybody that's at ground level or below 4 meters is in a zone where there is no exclusion zone. Exclusion zones only exist at heights above 4 meters. So the sort of advice we're hoping to simplify out of this, because we don't want you to try and interpret these pictures, is that the Yargis would say more than 6 elements for any of the bands mounted at a height of Z meters or more are compliant at ground level for all legal power levels. And then we'll give specific guidance for less directional Yargis or other antenna heights. So that's the work that's going on at the moment. It may not end up being this way, but that just gives you a flavour. And that will be published, hopefully, in the next month or so in a pre-assessed configuration too. Just to give you a little bit of faith, if we run the calculator on the same thing, it comes up with a compliance distance of 9.8 meters. With a directivity factor of 0.5, then of -5 dB, if I put that in and run the calculator again, then it becomes compliant everywhere at ground level. This is the sort of picture that what we're trying to do. It's a concept. The current calculators give this sort of gold section of a sphere. What we want to do is maybe to come up with a cylinder that says in that range of heights you need to stay that distance away, but for anything below that range of heights you're compliant everywhere, for example at ground level. So to summarize, we all need to try and use good practice to launch RF fields which maximizes the signal in the far field and minimizes the exposure close to the antenna. You can use the calculators to give you compliance distances, or you can set up and operate your station using pre-assessed configurations. As long as you manage the exclusion zones, don't transmit when somebody's present, or turn the power down, or move the antenna if somebody does come into an area, then you can prove you are compliant. If it's not demonstrated, you basically have to try a bit harder until it is. So a lot of people are saying this will be the death of amateur radio. It won't. It's quite simple to do the evaluations. Ofcom and ourselves have tried to explain how to demonstrate compliance simply. And what's more, Ofcom are more interested in helping us to comply than they are in proving we can't. So thank you for your attention. I must thank Ian, GM3SEK, and Peter, G4DSE, who've done an enormous amount of modelling work on this and are the kingpins in our team doing this work. So thank you very much for your attention. I'll prepare for questions.
Yes, John, indeed. I think there will be quite a few questions. We've had quite a few questions and comments and concerns, it's fair to say, so far. But if you'd like to ask a question for John and haven't done so already, then either do it now on either YouTube chat or on BATC messaging. And please don't forget to include your first name and your call sign if you have one. And if you can, try and keep your messages into one thing, that'll help me a lot to bring them all together. So let's firstly then, anyway, John, I hope they've given you a chance to have a short drink and a little break. I did see the first question I actually saw was from Laird Nigel Lawrence, G0MEJ, and says that I'm using a cobweb antenna, 100 watts in my loft, or use 10 watts only. So I'm not sure if you can give him enough information from that, but is that the sort of thing that you can use that calculator for?
You could do. We haven't yet programmed in the cobweb, but if you can look it up, or if you wait for us to add the cobweb antenna, then it will have a gain. It's going to be very, very small for a cobweb. The problem that a lot of people have with an antenna in the loft is trying to make sure that they stay far enough below the antenna for people in the bedrooms not to be exposed. But for a cobweb and a few watts, I haven't got time to do it online at the moment, but if you run that in, I'm absolutely certain you'll find at 100 watts that the distance is going to be a few meters.
Okay.
So you should be okay. If in doubt, then as he suggests, you could just turn it down to 10 watts.
Sure. John, actually just on this subject, while we've got a lot of other questions to get through, but specifically I think there was some confusion originally whether your family are also considered members of the public in this respect. So can you confirm that apart from the amateur himself or herself, is the public, is your family considered part of the public for the purposes of this?
The people who are excluded are any amateurs involved in running the station. So if you've got all your mates around who are licensed amateurs, you can do what you like. Your family are considered general public.
So considering, say something like a big field day, where most people, or all people probably, are going to be amateurs, you maybe haven't got quite the same concerns about close proximities at least.
Correct.
Okay. Right, so let's get some of these specific questions now, I think. Mark, M0JAV, asks, is the DL9 KCE calculator V1.5 approved? Are you aware of that one?
I am. It's ICNIRP Calc. Somebody asked me this yesterday, and I said I'd look it up. I think it uses occupational limits, in which case it won't give the right answers. But we have used all of their antenna figures to verify the antenna gains we got in our calculator. It is aiming for 1998 levels. In Germany, they operate a slightly different way, because you only have to do the calculations if the near field for your antenna extends beyond your property boundary. So fortunately, property boundaries don't come into our calculator, but part of the ICNIRP Calc is addressing that issue.
Okay. Yeah, thanks, John.
It also looks at our pacemakers, and you have to provide protection against people with pacemakers.
Yes, of course. Actually, while we're on that subject, you mentioned Germany, and I know that we have lots of viewers watching this from all over the world. I've already seen Belgium, call signs, USA, and everything. So just a reminder that although the basic principles of measuring will apply, and ICNIRP itself is a sort of international compliance, it's worth mentioning that the specific levels and rules that John has referred to tonight only refer to the English, or British, shall we say, system which is run by Ofcom. So all of the regulations and specifics, you should really check your own country for the actual limits. Now, Mark M7B, no, actually I'll go to Stephen first. Stephen G7VFY, he sent quite a few different messages, and I'll try and summarise them into one for you. He says, what about flat dwellers who have in common parts or gardens? And he says, where are all the people supposedly injured being exposed to RF? Well, I guess that's maybe asking why is this all happening. Looking at this, flat dwellers would need to have to go QRT, he says, so he's obviously quite worried about this and concerned. and all operating in parks. So I've tried to summarise Stephen's 4 little messages there for you. Have you got any comments or words of reassurance for him?
Yeah, well, first of all, fortunately, there are no cases of people being recorded as being seriously harmed by amateur radio. But there is one way that can simply demonstrate compliance, and that is what's called the low power limit. So if you have a look at this, this is a person operating on 20 meters using 30 watts into a half-wave dipole, which is a sort of antenna they might have, and they are compliant unquestionably. There is no required compliance distance because the average power is less than 10 watts and the peak power is less than 100 watts. So a lot of flat dwellers won't be able to operate at 400 watts, but they'll be able to operate quite successfully at lower powers.
Okay, so Stephen, some words of hope there for you, I think, and I think the message is to try and use the calculator to try and assess things firstly for yourselves. It's not something we can do specifically for everybody tonight, but I think what John is trying to do is help us, give us a guide to how we can start using that calculator. Mark M0JAV is saying, is having CCT coverage of the exclusion zone and promise not to transmit if anybody is in it, does that satisfy the requirements?
Yes, as long as you have a method for controlling the exclusion zones, and CCTV or PIR should satisfy them. Okay,
good, thank you. Kev G6ZDP says, what about mobile antennas? Can we use a camera to view the exclusion zone? Or some HF antenna that we purchase don't give any gains? I guess that's a similar sort of question, really.
Yeah, one of the problems, when we have a custom feature in the gain, I don't know if you are actually sharing my screen again, are you? Or?
We can do.
I just realised I explained the last one on the picture on the screen and the picture wasn't up. But we have built into the calculator a whole series of antennas, and we will be adding mobile antennas to that. So that was one question. The other half was CCTV, which we just answered. So.
Thank you. John, this might be a good point, in fact, in which to say, although your particular antennas that you're using at home may not be included on the calculator at the moment, John and his team are working very hard. They've been working flat on this for months and months and months, if not probably a year now on this. So if you have any particular data that you've worked out for a specific antenna and you can help them with all the modelling, you can imagine how many different antenna arrays there are. I know John and his team would be very pleased to hear from you. Isn't that right, John?
Yes, you're quite correct. I mean, this is in the this is the calculator, and all I've done is moved further down the sheet, and you can see that for each of the bands and each of the antenna types, there is a gain in dBi. And what we basically need to do is to verify those and fill them in. So if you have, for example, a cobweb antenna, we could easily put the cobweb in here, providing we knew what the gains were, and that would be added. But it's taken a couple of us quite a few weeks to go through and find the gains on the web in the same way as you do. Or we've had help from some of the manufacturers, some of the people, some of the big stores have helped us to actually find the gains of antennas we don't need. But we know that there are still many more out there. And the same thing for cables. This is the cable, again, per each of the bands, per the cable types, and the loss in dB per 100 meters. So.
Well, you can see there's a lot of work there, but if you can help John or his team with any of these antennas that you've either already modelled or you're going to model, then please help share. I don't mind if you don't sure you won't mind, John, explaining that what your call sign stands for at this point.
Yeah, I often say when I'm on the air, my call sign is Mike Zero, just another volunteer.
Exactly. So if you're watching this and think you can help, please do so. Let's get back to the questions now. David Stansfield says, the directivity factor is a new concept to me. It's clearly very important. Are these factors tabulated somewhere for a long Yagi, for example?
Not yet. What you can do is some manufacturers actually produce an elevation pattern. And if you work out the elevation angle, how far it is going down, then you can read the elevation pattern, how far down the pattern is from the bore site, and type it in. But it's doing the antenna gains is difficult enough. Doing the directivity factors would be even harder. Now, one thing that ICNIRP Calc, the German one that was mentioned earlier, did was, because they didn't make it spreadsheet based, they used a PC only program. They actually did do some calculations of the directivity factors, but only for a small subset of the antennas because it was so much work.
Yeah, okay, so that might be useful for some of the work. Let's go over to BATC now. We've got some questions being asked there. Brian G3ZOH says, if compliance distance extends inside a house, what are the options?
Well, once you can do more detailed modelling, but let's assume that you've done everything you can and your compliance distance is still inside the house. I would suggest buying some theatre tickets for the children, or finding some other way of making. I mean, usually if it does come into the house, it's only going to be a small distance. If you remember when we put up the pre-assessed configurations, providing your wire isn't actually going in your house within 2 meters of the people, you're likely to be compliant if it's a wire antenna. If it's a beam antenna and it's on the roof, then a good beam will radiate very little downwards at all, so you're likely to be compliant.
Yeah, in fact, on some words of hope here from G0FVT, who says, I used the directivity factor quoted for my 2 meter at 9 element, despite 400 watts, it's not a disaster. So there's a word of hope there for you.
Yeah, I mean, we had one guy who very early on was using a 4-on-4 beam at sort of absolutely ridiculous EIRP for his contest work, and he found that the compliance distance was only just over 20 meters. He was absolutely astounded.
Yeah, so it's not necessarily bad news, is it? I have heard as well in my club, and I'm sure you've heard it as well, there's some kind of thinking out there that if you're running 10 watts or less, then you'll be fine. But of course, it's the EIRP that makes a difference, and it's what that antenna is actually putting out, isn't it? So please don't think that if maybe you're a foundation licensee and you only can run 10 watts, that you're going to be necessarily okay. It still does apply to you, doesn't it?
It does, but equally true is that the majority of the systems that new licensees, I won't talk about people who are just starting in the hobby, are likely not to use these really directive antennas, and they will find when they run the calculator that they are compliant on the low power conditions. They don't have to understand and do all the detailed directivity factors and exclusion zone work.
I guess while we're talking about new licensees like M7s and also others who are at various levels, I guess for new courses and things, the RSGB will be looking at building this sort of, all about these sort of ICNIRP regulations, building them into the courses and building them even ultimately into the exams.
Well, certainly, I mean, there's 2 levels at which the information has to go in. There's the sort of license conditions bit, so I'm sure there'll be parts going in there. And I know that the exam syllabus review group are looking at that.
Yes.
We've also been asked to produce some information about the calculator and the other things, and we've said it's a bit premature while we're still trying to work it out.
Yeah, sure.
But certainly there will be something in the training, and not just for the exams.
No, of course. Well,
we intend to produce training for all amateurs. This is part of it, if you like.
Yes, absolutely. A webinar is a good way of talking to several hundred people, and ultimately several thousand will probably watch this afterwards as well. Let's get back to some more of the questions, if I may. On BATC, John G8EWG says, the situation in a small urban garden is extreme if if you have the added issue of the various zones, including neighbours' gardens, and the same neighbour will insist the antenna is already too high at 5 metres. His calculation, he says, seems to demonstrate that everything except a 2 metre handy into a quarter wave is difficult. Is that necessarily the case? Oh, he's actually added something here, by the way. I think there was a limit on the amount of messages there. How do we convince Ofcom our power meter is accurate, he says?
I don't think that they will question it. What they're really wanting us to do is, I mean, ultimately what's going to happen if they ever did enforce it, and remember my last slide says that they hope they won't ever have to, what they're going to do is to have a complaint, come out, take a measurement, prove that you are outside the limits, and if they can do that, then what they are likely to do, certainly in the early days, is to ask you to show them how you've done your evaluation, to help you correct any errors in it, and then ask you to change the way you operate in line with the revised calculations. But I really don't. I mean, I've given several examples tonight of low power compliance with a bit more than a 2 metre handheld. You know, you could get up to 10 watts EIRP average, 100 watts EIRP peak, and you are compliant.
Yes.
And that was a major change in this last issue of the guidance.
And which is, of course, the final one now. Is that the May 18th one when they released, they said they made their final decisions. Is that ever likely to change, either upwards or downwards, do you think?
If ICNIRP change their limits, the other possibility is there are another set of limits maintained by another group called the IEEE, which are the ones that were used in America. And, you know, they feed off each other. So it's possible that they might change, but I don't think it will only be the reference levels that change. I don't think they'll change much else.
No. It's worth mentioning, a couple of people have put down things like maybe the RSGB should have said that, you know, to the Ofcom go away. But I mean, it is Ofcom that makes the licence limits. This isn't something the RSGB have certainly thought up. This is really just something the RSGB are trying to help amateurs work out whether they can be compliant and how to be compliant indeed. I'm sure that we've got a lot to come probably in things like RADCOM in the future, maybe advice of different types of antennas maybe that we'll see that are particularly novel and maybe very directional so that you don't interfere with your neighbour's garden if you've got quite a narrow garden or something like that. But
yeah,
quite a few...
Sorry, the other thing that we're thinking about doing and in discussion with the board is actually saying if people want to review antennas in RADCOM or publish antenna designs, that it should be compulsory for them to publish some EMF advice alongside that.
Yes.
So we're considering that at the moment, putting the burden on the manufacturer.
That does sound very good advice, and indeed it might give some manufacturers and some designs of antennas an edge when it comes to these new regulations. So
well, certainly for a beam, the more energy you can get down the bore site, the less energy there is near to the antenna to cause EMF problems.
Yeah. Yeah, sure. So I don't want anybody at home to think that I'm ignoring some of their questions. Stephen Walters said that he doesn't live in a detached house with a 160-foot garden, and somebody else, Steve Telford, said that he's got a small garden with a public footpath next door, and he might as well send his licence back. But I'd urge you all really, and I'm an amateur just like you, to have a look at these, try and work through some of the calculations using the new calculator in particular, because you might well find there is something that you can do. And of course there will be a lot more published. I don't think any of this, you have to do this. I think the first stage in the UK is November the 18th. Isn't that right, John?
Yeah, there are 3 dates. Sorry, I had this in my notes, but I didn't read them out. There's November the 18th for greater than 110 megahertz. Then there's May the 18th next year for between 10 megs and 110 megs. And then it's November the 18th, 2022 for below 10 megahertz. And I tried to explain what the problem is below 10 megahertz. It's finding a reasonable way of simply doing the estimates from EIRP into the individual ENH fields. There's also the difficulty of peak fields being needed for electrostimulation limits in the 2020 version of the limits below 10 megahertz. So there's a lot of discussion and work going on trying to work out a practical way of doing the assessment in the various ranges.
Sure. Okay, so still watch this space. I'm going to go now. I don't have a person's name, I'm afraid. All I've got is Rolex watch, apostate. My 8-foot by 15-foot garden is ground floor. My neighbour's garden is next to mine. My other neighbours live above me. There's no separation. So he says that basically I've had it. Have I had it as an amateur in a flat like that?
Well, no, I think you'll find he can operate 30 or 50 watts with a simple antenna. And, you know, there's a whole QRP group out there who do it all the time. And they absolutely love the challenge of trying to get through on low power. Okay.
I have actually just seen that there's another message a bit further on. You can imagine how many messages are coming in at the moment, so it's hard to bring them all together. But Rolex watch again. Oh, it's the call sign actually is 2E0PPJ, I think. I was considering a loop, but confused on how to calculate. It's all very ambiguous, he says. So is a loop something worth considering?
Yes, loops. I think any antenna is worth considering. I mean, the one that we are challenged by at the moment is an inverted L. And we hope to get on to some of the verticals and inverted Ls, which, you know, are obviously good solutions to small gardens, and come up with the guidance for those.
Yeah.
I mean, if it turns out to be similar to the separation distance that we found for all the dipoles in the HF ranges, then, you know, a few meters away from a vertical would be achievable in most gardens.
Sure, okay. Going back again one final time, because it was about 20 or 30 messages on, I've seen another PS to that, I think, where Rolex watch, apostate, or 2E0PPJ says, can I operate an MFJ 1788X loop in a flat garden 15-foot by 8-foot on the ground floor 50 watts with no separation with neighbours? I mean, that's a detailed question, but do you know that loop?
No, I don't. You know, if there must be somebody either close to him or an amateur in nearby who can help him with following the guidance. So one of the things that I think we need to be doing is to train up the DRM team in these techniques, so that the local district representatives and the DRs can actually help people who are having difficulty with understanding compliance. Unfortunately, with the 6 to 8 of us that are doing it, although we have answered some questions, you know, we've had 10,000 emails now.
Yeah, we haven't got quite 10,000 messages here, but there's quite a lot, as I've just seen, because it literally 20 or 30 messages on with that. Anyway, I hope we've helped you, 2E0PPJ. I hope we've helped you a little bit there. The answer is to try them. If you've got a local club, they've probably got EMC officers. They might be able to help. Just don't expect, if I might say this from a neutral point of view, and as a club chairman myself, try not to just put everything on them and say, this is my setup, can I do it? You need to try and do a little bit of work yourself, I think. And after all, we've all passed our licenses at various levels. So we've all got to learn how to live within the regulations that go with those licenses. But I'm sure that the RSGB will be willing to help, maybe district managers, as you say, John, and also local clubs, I'm sure will be able to prepare to help you with this. So don't panic, we've still got quite a lot of time, but try and do a little bit of research and work yourself first, and then maybe ask for some help if you need any further later on. Now let's get
another great opportunity to volunteer, David.
Absolutely, yes, yeah,
Some
absolutely.
of the people watching have the expertise.
Yes,
volunteer, and we can pass the questions on to you.
Excellent. I mean, if anybody knows about that loop and has got one of those loops, then presumably they're going to be doing these calculations. So if you could help us, and if you want to get in touch with the RSGB, we could put that specific point to help that person out. But we have to move on to some others because you really have a lot to get through. Let's see, where do we go now? Someone has said already, in fact, G4 via FHL has said, Rolex can definitely recommend this mag loops. This minefield will be over, but the calculator is not good enough at the moment for mag loops, he says. So hopefully that will be sorted out. I've got Kevin.
Somebody has actually done a paper, which we're just in final stages of reviewing on mag loops. So we hope that was a volunteer who wrote to me and said, you know the answer? No, but I could help you work it out. and he has worked it out, written a very good paper, which we hope to publish soon.
Okay, well, that'll help answer Stuart's M0HBL then, or MBI, sorry, HBI says, will there be a book we can use like a pre-printed sheets to work on with as proof? So I guess there'll be some help in that way, and lots more will be published. But remember that John is also appealing for help with anybody who's done some of this modelling, so that that big table can start to be filled more. It's going to be some time, I guess, before it's going to be ready for print, because this is a constantly changing situation. Now, sounds like, where do we go now? David Stansfield says, sounds like PA2 is this factor. We should have had this information before going public. Well, okay, I'm not sure what that is, but we'll try and have a look at that later. It will help if you can keep messages together, though, I can say, because it feels like we've got several hundred messages here at the moment. Lots of information on dipoles and Yagis, but what about vertical antennas? That's from Bob, GW6RBZ.
Next on the list, as I said earlier.
Okay, all right.
There are some verticals in there, simple ones, but the more complex ones in the inverted L's are next on the work to-do list. Yeah,
just one question, a short question before that I missed. John MM3YVH says, why is this happening now? Well, I think you publicised it at least probably a year ago in Radcom. Was it something like that this was coming, John?
We've actually been continually running on the website, and one of the things that does sort of jar me a bit is when somebody says, why didn't RSGB doing anything about it? If you actually look at www.rsgb.org/EMF and scroll down the page a bit, you will see the hundreds of pages of interaction we had with Ofcom in the early stages, trying to persuade them to do less than they're doing now. But what they're doing now is much less than they were planning to do in the early days.
Sure, okay. And you can see on the screen now at home, there's the magic web address to go to find out lots more information and a link to the RSGB's calculator and everything. It's rsgb.org/EMF. Please don't ask your questions again, though. Can I ask you not to repeat them, because otherwise we really will be in a muddle here trying to work our way through them. We will get to as many questions as we possibly can today. So if I've got a question here from Matt, M0CUV, says, so if I restrict EIRP to less than or the same as 10 watts into my loft dipoles for HF between 7 and 50 megs, am I automatically compliant for all bands, he says?
I think there's a little bit of the EIRP includes the gain of the antenna for the dipole. So if he restricts the EIRP from his antenna to less than 10 watts for all of the bands, then he's compliant. But it is a separate calculation for each of the bands. For example, the cable attenuation changes with frequency.
Okay, thank you, John. John G0EWI says, my hex beam is only 4.5 metres off the ground. Will it comply to the new regs? I guess the thing we don't know from that is what power he's running, but have you got any general advice about a hex beam?
No, other than it is, I'm pretty sure, one of the antennas that we have in the configuration. I'm just checking now, but I'm pretty sure that, yeah, the hex beam is in there. It's got a gain of about 5 dBi in the bands it works on. And the height is, I suspect he will need a separation from the hex beam. I just don't have time to run the calculations live on air, but it isn't. If he goes to the 10A calculator, he'll be able to come up with an answer or a number of answers quite easily.
Okay, so John, there's a bit of help for you there as well, if you can download the latest calculator. If you'd already downloaded a calculator as well some time ago, I know it recently changed to version 1, I think now, isn't it?
The Ofcom calculator's at version 1. We haven't. What the Ofcom calculator between 0.1 and 1 has done is to incorporate some of the stuff that we've had in the RSGB calculator all along, like the 6-minute average and the way to calculate power. What it hasn't done is included feeder losses, specific cable types, specific antenna types. So now that Ofcom have gone to version 1, by all means use it. It's a bit harder to use, has less numbers to put in, but you have to do a lot more work to get the inputs. But if you go to our 10A version of the calculator, which is on our website, then it does have changes that mirror what Ofcom have done.
Okay, so a little bit easier to use though, just because really the RSGB have done one specifically for radio amateurs, whereas remember that these new rules apply to all spectrum users, anybody who basically transmits and uses an Ofcom license, which is much more than just radio amateurs. ADG6AD says, my antenna is a full wave loop, 80 meters. Which option should I select from the calculator?
I guess the answer is there will be a full wave loop for vertical and horizontal, but it isn't in on the current version. It is being worked on. Okay,
thank you, John. Kevin,
there's a delta loop in there, but there isn't a square loop.
Okay, thank you. Kev G6ZDP says, what about the HF antennas? I have a vertical CHA 250B, but I cannot get any information on the gains. I've emailed Comet, who I guess are the manufacturers, and the distributors, but no one can tell me. How would he work out the gain of something like that? Has it got to come from the manufacturer ultimately?
No, if if he can't get it any other way, then he'd have to do a neck model of it to calculate the gain. But I can't believe that somebody somewhere hasn't got it.
No. Again, so if you have got this at home now, and you've done that for that particular antenna, if you could let John have that, with something that all this information, we can collaborate and help John and his team. 2E0GFY, Darren says, will you be adding multiple antennas to the calculator?
No. But I did try to explain during the presentation how you use, I'm assuming you mean simultaneous.
That's all I've got, I'm afraid, John. So I guess.
Just read it to me again. Sorry.
Yeah, of course. Let me just go back to that. Will you be adding multiple antennas to the calculator?
Sorry, I was answering the wrong question. Yes, we will. We already have a four Yagi up. 4 times Yagi, and there is a separate calculator being considered for the higher frequencies, which will certainly have a lot of multiple antennas for a given beam. 4x4, 4x1, 2x2, different spacings.
Okay, so it's coming if it isn't there already. William GI8WFA says, or asks, how much isolation in distance does an intervening cement cavity wall afford one from a radiating antenna and, for example, operating on 7 megs?
I don't know. It's a question we've been asked lots of times. We have to work worst case, which is to assume it absorbs nothing.
So that all of that energy would be transferred to the neighbour?
Well, it will go through. I did do some work recently in conjunction with some other work on looking at the radiation at very low frequencies from high power devices, and I used my kitchen hob as a source, and I measured the field strength inside the house and outside the house through the brick wall, and the difference wasn't really detectable. So the answer is not a lot.
Okay, so not really much attenuation.
That was at very low frequencies. That was at 100 kilohertz.
Okay, this was at 7
that's what
megs.
the hobs are at. Yeah.
So really, you've just got to assume that there's no absorption in the walls and that all of that can be transmitted.
Unless you can find out what it is. If you can find out what it is, then you can feed it in to the calculator in the other losses.
Like attenuation that has, yes, okay. Thank you, John. G4GCX says he's mobile operationed with an original G-whip with an extender rod mounted on the front of the back of the vehicle, similar to UN vehicles. So I guess he's asking there. He hasn't really asked a question as such, but you know, maybe we could just talk about mobile because we haven't talked about it yet, on vehicles, cars, vans, that sort of thing. I guess these rules and regulations will apply to those. So how do you begin to working out how close somebody's going to be if you're driving along a road and transmitting?
Well, we actually put quite a bit about this on some of the stuff on the website. But I mean, if you are driving along, then a person that is stationary, all the people that are stationary or travelling in the opposite direction or at different speeds, are unlikely to be close to you for 6 minutes. So you're averaging, if you pass them in a second in 6 minutes, then your transmission time towards them is in fact 1/360.
Right. So it's a lot less.
So that will put it down to a tiny amount. The next thing you have to consider is the person in the front seat of the car next to you is not an amateur while you're transmitting. And you'd have to do that model, and that is really quite difficult. And the other thing is if the car is parked up, say at the traffic lights, and you've got pedestrians walking across in front of you, then to stay compliant, you would probably need to not transmit while people are close to you for extended periods.
It's quite complex then for mobile operation.
There has been some modelling done, and it has been published in RADCOM, but it is very, very difficult. I mean, we're having enough difficulty getting simple antennas to give us stable results. And we define stability by using two different modelling and setting them up so they give the same answer. So if there's any artifacts in one, then it won't give the same answer as the other one. But it's very difficult to do that for the antenna, yet alone the bodywork of the car and the gaps of the windows and everything else.
Yes, because I mean, I guess some of the car is going to act a bit like a Faraday cage, but then you've got windows, which presumably most glass will just allow most of the...
It's not earthed, is it?
No, that's true. Yeah, so it could become part of the radiator even, I guess.
It will radiate to some extent. I mean, it will act as a big capacitor effectively, so it will have some Faraday cage like, but I don't like the concept of transmitting at high power while moving.
No.
I'm worried about the EMC aspects of interfering with the control systems in the car.
Yes, as there are more and more electronics getting into a car, I guess that's something to consider.
We're talking about hundreds of antennas on a modern car, built in.
Yes.
To do, for the radio, the Bluetooth, enormous, and even for some people are transmitting signals around. Your tire pressure measurement stuff could be transmitted.
Okay, complex subject as we're seeing. Henry McDonald has said 25 watts on 2 meters into a quarter wave whip on a stub mast on an external wall at 10 meters above ground level. Nothing to see here, so do I just make up a sketch and staple to my license, he says.
If he can certainly make up a sketch and do a calculation, he can find the custom gain, use the custom feature to fill in the bits that aren't in the tables, and that's all you need to do, just keep a record. Good,
okay. David M0JAV says, why doesn't the calculator show all calculated distances for 40 metres, 80 metres, etc.? Ofcom compliance and horizontal separation are invalid, ?
Don't understand.
No, it's a difficult one, isn't it? Let me just read it again and we'll see if we can work out. It's from David, and he says, why doesn't the calculator show all calculated distances for 40 metres, 80 metres, etc.? And then he's put, it's got a question mark at the end, Ofcom compliance and horizontal separation are invalid. So is he asking, is the Ofcom...
Oh, sorry, I know what he's saying. He's trying to do a calculation below 10 megahertz.
Okay.
And at the moment, the calculator doesn't support it, so it flags up invalid in the answer box.
Right. And of course, that's going back to those dates again. I believe that was next November, isn't it, that you've got for frequencies under that?
Correct.
So we're talking about November 2022, just to no avoidance of doubt for depending on when people watch the recording of this. Okay, but nevertheless, it's worth starting to think about now, but hopefully the calculator will be building up more of that sort of thing now. So what frequencies are we looking at now, John, that really are the ones that we need to start thinking about, that are going to be where we're going to have to comply by the 18th of November 2021?
It's above 110 megahertz for the first one.
So basically it's 2 meters and above initially.
Yes. In amateur bands.
To all intents, yes, for amateur bands. Okay.
I've actually got shared on my screen at the moment. If you want to just pop it up.
We've done that.
I can't release this yet, but this is the prototype of the 2020 limits calculator. And it's also running against the 98 limits. So I don't know if you can read there, but for the particular example that's set up here, which is 40 meters, because it's now working below 10 megahertz. The ICNIRP 1998 limits would have given you 2.3 meters compliance distance, but the 2020 have brought that down to 1.27. So at the lower frequencies, when we do get the calculators approved, then the distances will be even smaller with 2020 limits than with 1998.
That's quite striking. I mean, that's half the distance, wasn't it, basically?
Yeah.
With the new compliance, with the new 2020 regs. So
yeah.
Okay, we've still got lots to get.
That's an unproven piece of work. But,
okay, but it's good for people to see the sort of work that you're doing, though, and understand all of the hard work that you're putting in behind the scenes, and your team as well, John. The RSG, we've got Mark M0JAV says the RSGB calculator doesn't work on my version of Windows 10. It opens, but it doesn't let me put in any values. I'm just wondering, could that be the same problem in terms of under 10 megs, do you think?
No, there are some compatibility issues. I don't know what. We've only just released a 10A, and I haven't heard of any incompatibility reports yet, but I'm sure there are some.
Okay. Well, just to help.
The earlier versions, some people did report problems with earlier versions of Excel, but we did get 9E working on quite a lot of the free spreadsheet programs as well, but I don't have them all. So if you have various different things, again, run them for us and send us in the reports, and we'll try and
so you can imagine how many free spreadsheets and different spreadsheets there are on the market, and some of them free and everything. So, but Mark, so if you can let the RSGB EMC team know the specific version of Windows you're using and the specific calculator that you're trying to load it on, then maybe they'll be able to help, and they'll certainly try and solve that problem. Need to move on. We're already bathed in RF. Any idea of a typical exposure level in Great Britain as a result of broadcast radio, FM and AM? That's from John DeLibito.
I don't have the answer, but if you look up on the web the power and you feed it into the Ofcom calculator, it will give you the answer.
Okay, thanks. That was John's call sign, by the way. I just saw a bit later on was AB3ZI. Clive Turner says, will all non-resonant antennas be modelled, e.g. inverted U or BOG type? That's G1WZM. I guess it's the same answer that you're going to get round to them, but there's an awful lot to get through.
No, the inverted Vs have all been done.
Have they?
On the website. Yeah.
Okay, Clive, so have a look at those, please. Thanks for the webinar and all the hard work. So there were some thanks. There's a cheerful one for you there. When can we expect, calculator to cover low bands? I'm more concerned about ground-mounted verticals than beams 60 foot up. That's David G0OIL.
We've just got to validate the prototypes of the calculator that we're working on and get an agreement as to how we handle the areas close to the antenna. But the other thing that's coming along is a heck of a lot of work on the pre-assessed configurations. So for a goodly number of the antennas that are used at HF, we will be able to give pre-assessed configurations, and the ones that we've done have had numbers like 6 meters antenna height and 2 meters separation, so they shouldn't be frightening.
G0FVT says FWIW, the datasheet for my F9FT 9-element tonner does provide some great pattern information. The EIRP off-axis is a long way down the list, so there's some hope for people who are looking for antennas that might be something they can use. I mean, the G4GCX says the RSGB should now press for automatic permission to be granted for licensed operators for 11-metre high towers. As I understand, they are doing so in France, is what he says. But I guess this is all down to Ofcom, not the RSGB.
That's planning, is it? He's talking about there?
Pardon?
Is he talking about planning there? Or?
I guess so, is what he's saying, for press for automatic permission to be granted if you've got 11-metre high towers. But
yeah, well, that's completely separate to Ofcom, of course.
Yes, of course. What are US? This is from Chris 7472. What are US apartment dwellers to do? Any compliant solutions that can be mounted on a chimney and not look like an alien landing beacon? He says.
Well, we're working with the guys in ARRL, and they are suffering the same thing because FCC have just decided to change their rules as well, so it is difficult.
Yeah, Kevin has come back, G6ZDP, and says, I did say to one supplier that they need to put the gains on some of your antennas as this could affect your business, but they've ignored his emails, he said. So if you're a manufacturer or a supplier in the UK watching, then please, put pressure on the manufacturers to put this sort of information, because it's now something that's not going to be optional. It's something that really buyers of your equipment are going to need to know. It's certainly going to make a difference to some people who have restricted gardens. So let's hope that some of them are watching. Terry G3.
The other piece of work that is going on at the moment is with generic classes of antennas. For example, just like we did with the various sizes of dipoles, we came up with quite, 6 to 9 meter answers, but it covered everything. There's currently a lot of work going on Yagis, which will appear in Pack 2, and that will say that for something like for antennas above a certain height, let's take 11 meters as it might be an example, then all of antennas of more than a certain forward gain are compliant. So you won't need to know the exact answer, you just need to know it's above a certain value.
Yeah, and it could help people make those decisions about what antenna might work. Terry G3VFC says, how does the near field energy coalesce around a beam, say 40 degrees off bore site? I.e., can it actually be modelled, he says?
The answer is yes. And if I can share, it was on one of my slides, so I'll try and share the screen again, and then project it. There you go, there's a model. This is for all the heights and for all the distances, and these are the field strength contours. So you've got the 10, 50, 100, 200, 300, 400 contours. And anywhere outside of those contours is far enough away not to exceed the limits. So these aren't just the patterns, these are the patterns reflected with the limits and the absorption. But you could actually take a measurement off this. Okay,
thank you for that. And is that something that now exists, John, or is that to come? Is that the prototype at the moment?
We won't necessarily be publishing each of those, because he asked me could it be modelled, and I say yes, it could.
Okay.
But they change so much with everything we do that we won't be publishing those. We'll be publishing the guidance data that we extract from those, so that they don't have to do the hard work of understanding them. But they can certainly be modelled.
Okay. Darren 2E0GFY says, on the calculator, can you find a way of showing that you're using the latest version? In other words, will that be under the About tab, or what? He just wants to make sure, I think, that he's actually got the latest version on his computer.
Okay, well, if you look on, the only way you can they do all have. I've got the wrong one. Not the new one. If I go back to the old one, they do have a version number on the front sheet, round about there. Look.
Okay, we'll be showing you there. Oh, there we are.
The current release one is 10A.
So it's towards the left, towards the bottom of the page, isn't it? It's
on there at the moment. We could put it somewhere else, but we wanted it to be in the section that prints out, so that so we know which version of the calculator you're using if we get asked.
Yes.
Or more appropriate.
Thank you, John. Thanks very much for answering that. We've got a couple of questions now. Two people at least want to know this, from Bob L. Not sure your call sign if you have one. And G4FHL says, why has the mag loop been removed from the new calculator? Because it was in the early version, he says.
I believe that the generic mag loop has been removed and replaced with two more specific mag loops.
Okay.
That's the feeder types, isn't it? Not the loops. There you go. We've got the Zero baby loop and the Zero MIDI loop have been put in because I think that was one that ML and S were able to give us some information for.
Okay.
So we've taken out the generic loop because it fell somewhere between those two.
So the loops are there, but they're specific loops that are there.
Yeah.
So I think everybody at home as well, if you can help here by, I think, putting pressure on the suppliers, who ultimately will put pressure on the manufacturers to give John and his team information on the antennas, because it will help to make that complete. And don't forget as well, if you modelled any of these the antennas that are not already on the calculator, you could certainly help John and his team a lot, and the whole amateur radio community, by getting that information to John and the team so that they can be put onto the next version of the calculator. The next question comes from G0FVT. Is there any scope for a different integration period? 6 minutes is a little short. Many will be in constant transmit for that period, but overall a lower duty cycle. Thanks for all your efforts as well, he says.
I'm afraid not. The ICNIRP limits are specified for 6 and 30 minutes. Okay.
So that's set then. G0OIL says, John, you showed E and H fields for less than 10 megs. Would a simple field strength reading be okay rather than modelling? I have the device used in DL for this purpose, so could do this measurement.
Well, just like when we do the calculators, we have to follow a known standard, and the calculator that you're looking at here is following ITU-T K52. You can use any calibrated instrument providing you follow a standard. Now, the one that Ofcom have said is acceptable is ITU-T K61. So if you look that up, that will tell you what you need to do to take a measurement. And once you've got past page 5, well done.
Okay, all right.
It's quite frightening.
John G0EWI says, can I use the reasoning that my antenna needs to go higher when seeking planning permission?
It's worth a try.
I guess the further away you can get it from people, really, the public, that's what it's about, isn't it, generally?
Well, it's unlikely to win, I think. It's like one of the methods of protecting is to go and put little signs in your neighbour's garden saying, you're now entering the exclusion zone for my antenna, and if you come any closer you may be subject to excess non-ionising radiation. It's not really a start.
May I apologise as well. Earlier I made a little mistake here because I said US, meaning United States, but he actually meant us as in first person plural, not United States citizens. So I'm sorry about that. I think you still defined we got the question though, all right. A concrete wall, does it contain rebar? If so, rebar I guess is metal bars and things like that. If so,
Reinforcement bars, yeah.
okay, reinforcement bar. I didn't know that's what that stood for. If so, is that a Faraday cage then, do you think?
No, because the rebar has big holes in it, and it will only stop certain frequencies, and B, it won't be bonded together very well. There's likely to be lots of rusty bolts in there, and of course rusty bolts re-radiate, don't they?
Yeah, and I guess as well they're not going to be connected to anything in particular like an earth or anything like that either, are they? Which isn't going to help.
Well, we had one guy who genuinely asked the question, what about if I put up a big steel plate, will it provide a shadow the other side of it? And the answer is not really, because it will just re-radiate much closer to the person than the antenna was in the first place. It'll have a certain parasitic element and re-radiate. So getting a big metal sheet connected 0 ohms to earth is not easy.
So aluminium wallpaper isn't an answer then?
No.
Okay. Alistair G7FTP says, if I say transmit 50% in 6 minutes, can I never transmit for more than 3 minutes? I guess they're talking about averaging there for times.
Yeah, well, you can, but I mean, the safest thing sometimes is just to set it at 100%, the transmit in 6 minutes. Things like FT8 and stuff, the mode factor takes account of that, so you need to put 100% in. But it's the rag chewers and the contesters that are going to be up at 100% most of the time.
Yes, with either very long overs or lots of short transmissions, I guess.
Yep.
Nigel says, as G0MEJ says, will the calculator work with Mint Linux and OpenOffice, for example?
A number of people have said it works. There is a problem with Linux and OpenOffice with the cell protection that we've put on. We've only put cell protection on to stop people accidentally overwriting the formulae. But if you turn auto-save off in OpenOffice and LibreOffice, etc., then you stand a better chance of getting it to work. But there is an issue with some of the free programs with cell protection, which we will either fix, or eventually, when we finish all of the work, we may actually get it coded up as a website app, so that you just go and fill it in on the website, in which case it doesn't matter what software, because it's provided by the web.
Okay, so most should be reasonably compatible, most different.
Well, we've had a lot of complaints from odd people, but we sometimes find that, Fred says it doesn't work, and Bert tries it and says it does. So I don't know. It's
difficult. Well, I guess you're doing it generically for Excel, and so most programs that were compatible with Excel spreadsheets should run, I think is the answer. And there are a lot of free ones, it has to be said, out there as well. So if the one that you particularly have doesn't work, then maybe it's worth trying to download another free open source one.
Or to find a friend who's got a computer with Excel on that does work.
Sure, okay. Jeff OS8NT over on BATC says, we've had this in Belgium since 2006. UBA has program with all kinds of antennas available, developed by ON4UN. So that's what Jeff says over in Belgium.
I haven't seen that one, but if he can send me the details, and that gives us lots of more antenna data, we can feed it in. I mean, the reason why we are sticking at the moment with the Ofcom formulae is that they do accept the results. If we use other people's formulae, then we're going to have to prove that it works. And I get lots of people saying use the VK3UM, use ICNIRP Calc, use my favourite friend's one, but there's just too many of them for us to evaluate.
Of course, okay, but we have actually got, Jeff has put that information up on there, and I'll share that with you later, John. I'll put it on an email tomorrow for you, so you can have a quick look at that anyway. We are getting, you'll be pleased to know, just about towards the end of the questions now. I'm sorry, this feels more like a grilling than a webinar for you, but you will be pleased to know lots of people very appreciative. I'm not reading every one of those out, but lots of people are very grateful for what you've been doing there. In fact, I'll just read one of them. In fact, William GI8WFA says, thank you, John, for your answers and your valuable time. Thanks for all your hard work. Most appreciated. There we are. And I'm sure lots of other people agree with that as well. I mean, let's face it, we're human. None of us particularly like change, and this is definitely a change to our license conditions, isn't it? But you know, I know that you and the RSGB team are doing lots to try and help here, and it isn't just for RSGB members either. I mean, you're making your work available to anybody to use. So, as I said, I've said it once before, but I'll just say it once more again. If you can help, and if you've already done your antenna modelling and you find that your antenna are not on the RSGB's calculator, please share them with John and his team, because it will help him to help lots of other people as well.
And we mustn't forget our friends in the US. We've got some real experts who are amateurs in the US who are on our team, and they are, you know, checking what we're doing. And one of them is the world's expert on limb currents, as it happens. And he's written all the papers about it. So, you know, we are fortunate to have a great number, or a number of great expert people, far more expert than I am, helping us with this.
Yes.
And I should apologise in advance that I'm sure that I will have got one or two of the answers wrong, but I'm only human. Of
course you are. But we're very grateful for sharing this information. And you can see now on the bottom of your screen there, the rsgb.org/webinars. And if you replace webinars with EMF, you'll be able to get John's departments and his team's work on there all about EMF. So it's rsgb.org/EMF. We are, getting towards the end of our questions and things now. Bob L says, is it okay to use the baby loop figures for an MFJ loop? That's from G7EGN.
I would certainly start off that way. Unless you can get better numbers from MFJ, then use those. And if you're a bit worried about them, add 1 or 2 dB to those figures and rerun the calculator. If you're still okay, then you've got a bit of margin, haven't you?
Okay. Thank you. Clive G1WZM has come back and says, I was asking about terminated antennas like inverted U, not V. I'm sorry about that.
Sorry.
That was possibly me as well. Specifically non-resonant travelling wave types, including beverage on ground.
Well, beverage is a receive antenna.
So on the inverted U?
I'm not familiar with it, but I'm sure that, you know, if there's enough people want it, we'll try and get it working. I'm sharing the web page in case people haven't seen it.
Yeah, well, we'll go to that now. So remember, this you can find, and you can go to this rsgb.org/EMF. We'll get you here.
And what you'll find in here is links to the Ofcom guidance, what you need to know as an amateur radio, guidance on EMF compliance, the new license conditions, the ICNIRP 2020, lots of other support information about 2020, EMF1, which is what you need to know, the calculator link, the calculator demo video, which has now had 9,600 views, the pack 1, and down the bottom here, a lot of people said, why didn't you do anything about it? Go and read a few of these papers. There's hundreds of thousands of hours gone into the preparation of those papers. So,
yes, well, I certainly,
this one page.
I remember reading about it over a year ago in Radcom as well. So, but John, anyway, thank you ever so much. You'll be glad to know I'm going to finish on a really positive note here, because again, not to wish to point out everybody, I think we've answered most of the questions. I apologise if we have missed any, but I want to just read this particular one here from G0OIL. Says, brilliant work. Thanks ever so much. We all owe you a beer or two at the next convention. Well, I reckon with several hundred people watching, that's quite a lot of beers. So you may have to spread those over a few days, John.
Yep. Well, thanks very much. It does keep us smiling in the darks of midnight when we're trying to find the last error in the spreadsheet.
Of course, I'm sure. I know, but we really do appreciate the work you've done. A reminder that the RSGB haven't made these rules up. This is an international regulation, really, that Ofcom have just adopted and enforced in the UK. But we're really grateful to all the work that you and your team have done, John. So once again, thank you very much to John Rogers, M0JAV, who's the EMC Chair of the RSGB. Thank you, John.
Thank you, everybody, and thanks for your attention.
Lovely. Thank you very much. And that concludes this webinar. And thanks once again to our guest, John Rogers, M0JAV. We hope you've enjoyed this Tonight at 8 and that you'll join us again next time when we'll be getting an introduction to meteor scatter communications. If you'd like to see details of that and other webinars or send any comments or feedback, please visit rsgb.org/webinars. And remember, if you subscribe to the RSGB's YouTube channel, you'll be notified of all upcoming Tonight at 8 webinars, as well as other new videos and presentations from the Society on a wide range of amateur radio topics. But until next time, this is David G7RP signing off and clear. Bye-bye.